CRaC Coordinated Restore at Checkpoint is an open JDK project. The goal of the project is to provide a system with checkpoints that enables you to create a checkpoint from a running Java application, and it helps you to solve some of the problems related to startup and warm-up times. So restarting a checkpoint is a lot faster than starting a jar file. To demonstrate what can be done with CRaC, I created a simple example application that you can find on GitHub. It was based on an already existing example within the CRaC repository, which shows you how you can use Jetty. I added a PostgreSQL database and also used some example code from another blog post. The goal of this application is to load CSV files into memory and return the first 100 records of such a file. I ran the demo on a Raspberry Pi with Azul Zulu with CRaC included. On the README file of the repository you can find all the instructions to initialize the database, make the user account and stuff like that. You can run this on a Raspberry Pi because that's a Linux machine, and the full functionality of CRaC is available on Linux with the right OpenJDK runtime. Let me show you on a Raspberry Pi. I have this empty directory where I want the checkpoint to be created, and that's also the location I give as an extra argument when starting the jar file. You can see that it takes about 5 seconds to start this jar file on this Raspberry Pi. Now we have a web page available which lists all the available files which can be loaded. When loading the smallest file, then we get a very fast result within 400 milliseconds. So that's unzipping the file, loading all the data in there into Java objects, and then returning the first 100 results. Now, if we take the bigger files, of course, this takes a lot longer. It is more to unzip and there's more to convert into Java objects. We are already on 2 seconds for this file. And if we go even to bigger files, then you see this needs 7 seconds to load. And the biggest file with 1 million records takes about it takes about 15 seconds. But now all this data is loaded into memory, and if we request the same file again, you see that we immediately get results. So the file which was 15 seconds now returns in a matter of milliseconds. All the actions and the durations are stored in the database. And as you can see, we don't have a checkpoint yet, so in a second terminal we are using J command to trigger the start of the creation of the checkpoint. So you see already in the second terminal that this has finished, and in the first terminal we see all the ongoing actions while creating the checkpoint, and at the end the application is killed. So now our checkpoint is ready to restart, and as we can see, the application is not running anymore. Now let's go to the restore. The command is different, so we don't load the jar, but we load the checkpoint. As you can see, this is available immediately, so we don't need that full 5 seconds anymore to start the application. And if we load the big data set, we immediately get a result within milliseconds. So 6 milliseconds in this case, 4, 15. So within milliseconds, all that big data is loaded.